Standard 7th, Subject Science, Lesson number 18, Sound, Production of Sound. How are sound produced? See children, you have already studied this in previous standard. How are sounds produced? When a song is being played on a radio or a music system in the house, place your hand on its speaker. What do you feel? Yes, correct. You can feel vibrations over there because sound is generated by the rhythmic vibration of an object, and we can hear the sound as long as the object vibrates. But when we touch the vibrating object with our hand, the vibration stops and we no longer hear the sound, right? So sometimes we can see the vibrations, but sometimes the vibrations are so minute so that we can't see those vibrations with our naked eyes. Now, source of sound. The object due to which sound is produced is called the source of sound. Vibration is necessary for production of sound. When the vibration stops, sound also stops. Yes, just now we have discussed when we are placing our hand on speaker or any object which is vibrating, then if vibration stops, then sound also stops on it. On speaker we can't stop that sound because it is louder. Okay, as long as the object vibrates, the sound is heard. Propagation of sound. When sound waves spread in all the directions from the source of sound, it is called propagation of sound. Now, what is medium of propagation of sound? The substance around the source of sound is called medium of propagation of sound. So children, all these points you have already studied in previous standard, that is in 6th standard. You have studied many examples of sounds, yes, like bursting of crackers, clapping, lightning strike. Okay, so all these examples you have studied in 6th standard, right? Children, you might have seen that when a stone is thrown into a calm water of lake, waves are generated and those waves reach up to the banks of the lake, right? So vibration reach our ears through the air in the similar way, same way. Okay, and when vibration reach up to the ear, we can hear the sound. Okay, now look at this picture. This is what? Tuning the instruments. Do you know how singer tunes the instruments? Okay, or how singer ensures that the tanpura will produce the required notes? Yes, correct. By adjusting the tension in its strings. And what is mean by adjusting the tension in it? It means that instrument is getting tuned. Okay, that adjustment is called as tuning the instrument. Okay, now tabla player. Tabla player also tunes the tabla by hammering the pegs to adjust the tension in the diaphragm of tabla. To tune an instrument is to adjust how high or low the pitch of the notes produced will be. Okay, and the pitch of sound depends on its frequency. Okay, now do you know what is sa re ga ma pa da ni? Yes, correct. It is what? Indian musical notes, right? And these notes are increasingly higher pitch, right? And in scientific terms, frequency is measured in pitch. What is meant by pitch? It is measure of frequency. Now children, what is this? This is tanpura, right? When the string of this tanpura is plucked, what happens? The string can be seen that it is vibrating. After plucking, you can see vibrations, and two ends of these vibrating strings are still. In between, you can see that the string is vibrating, but both the ends at both the sides at the end it is still, okay? And as it vibrates, the string moves to one side of the central position and comes back to the central position, and this motion of the string is repeated again and again at fixed intervals of time, and this motion is called as periodic motion. Children, you might have enjoyed swings in garden, right? Yes, or at your home also. So, what exactly happens when you're sitting on swing and you're taking swings? You're enjoying it. What happens exactly? See, earlier in beginning, it is at the central position, and when you start taking swings, that time it goes forward and backward. So when the swing moves from one end to the other end and returns to its starting point, it is called that it has completed one oscillation. Okay, that much motion, that much path of motion is called as one oscillation. And the back and forth motion of an oscillator on either side of central position is called as oscillatory motion. Okay, understood everyone? So I repeat once again, when the swing moves from one end to the other end and returns to its starting point, it is said to have completed one oscillation. And this back and forth motion of oscillator means that swing on either side of central position is called oscillatory motion. Now let's discuss one more experiment. Okay. Look at this picture. A rubber band is stretched over a porcelain ball. Now, what happened exactly with this? Okay, to this rubber band. If you'll apply some force on it, and if you'll pluck it, it will create vibrations on it, and you can hear sound. If you will apply more force, you can hear louder sound, and vibration also will be greater. Yes, more vibrations will be there. Look at this third picture. What is there? One ball is there. Okay, see, I'll explain this experiment. Take a strong thread. First of all, you have to take strong thread about half meter long thread you have to take. Then tie a small iron or woolen ball. You have to tie one small iron or woolen ball to it and suspend it from a support as shown in this figure. Okay, you have to hang that thread somewhere so that it will take OA position as shown in this figure. Okay, it will look like this. Then This oscillator is called as pendulum. Understood what is pendulum? Yes. So after this you have to give oscillatory motion to the pendulum. Okay, just you have to push it. That ball you have to push slightly. The maximum distance between the original positions A of pendulum and the extreme position B or C is called amplitude of oscillation. Means maximum distance, how much maximum distance it can take up to B and C point. That maximum distance is called as amplitude of oscillation. Okay, and in this figure AB or AC is amplitude of oscillation. Now look at this picture. What is there? Stretched rubber band is there, right? So a stretched rubber returns to its original state when it is released, and this property is called elasticity. When a stretched rubber band vibrates, elasticity is at work. Now let's discuss about time period of oscillation and frequency. The time required by an oscillator to complete one oscillation is called the time period of the oscillator. The total motion. Now look at the figure which is given in your textbook on page number 120. Okay, 18.2 diagram is there, 18.2 figure is there. Okay, in that last one, just now we have discussed, no, the pendulum one, that figure you have to see. The total motion B to A to C, C to A and A to B in the previous activity, means that only, is called one oscillation. So we can write frequency small n. Frequency is equal to what? 1 upon time period of oscillation capital T. So that we will get the formula frequency n is equal to 1 upon T. Okay, this is the formula to calculate frequency of oscillation. So frequency is what? 1 upon T, time period of oscillation. Frequency is the number of oscillations occurring in 1 second. The unit of frequency is hertz, which is written as capital Hz. Okay, 1 hertz means there is 1 oscillation in 1 second, and 100 hertz means 100 oscillations in 1 second. So whatever number of oscillations are completed in 1 second is called as frequency of oscillation. So children, next part of this lesson we'll study in next video.